Assalamu alaikum and welcome to Mathcast with Faria Yusuf. And today the lesson is about differentiation, past paper questions. So I've collected some questions here from past papers for extensive practice. And the first question that I have chosen is from Winter 2020, Paper 1, Variant 3, and this is question number 8. So the first part of the question says, the equation of a curve is y equals 2x plus 1 plus 1 over 2x plus 1 for x to be greater than negative 1 by 2, and we need to find dy by dx and d2y over dx square, meaning the first derivative and the second derivative. So let's write the equation first. It's y which is equals to 2x plus 1 plus, I'm taking 2x plus 1 from the denominator to the numerator so that 2x plus 1 will have a negative 1 as the power. So if I need to have my dy by dx, then the differential of 2x is just going to be a 1 plus 1 gets eliminated, and then I should have here negative 1. It's a composite function for 2x plus 1 to the power negative 1. So I'll say it's a negative 1 times 2x plus 1, and then negative 1 and a negative 1. And then I will be differentiating the function within the bracket, which is 2x plus 1. So here finally I can say that my dy by dx should be equal to a 2 negative 2x plus 1 to the power negative 2, and then it's just a 2 here. So this is going to be my dy by dx, which then shall be equal to 2 minus 2 divided by 2x plus 1 the whole square. So this is going to be the first differential for this given y equation, y in terms of x. Now the second part of the question says where I shall be getting the second derivative. So I'll say it's the first derivative dy by dx, which is actually equal to 2 minus 2 and 2x plus 1 to the power negative 2 here. So to get the second derivative, it's d2y over dx square, and this then shall be equal to 2 being a constant gets eliminated. After that, I have a negative 2 for the second term. This negative 2 shall get multiplied by the negative 2 from the power, and then it's 2x plus 1 to the power negative 2 and a negative 1, and then the differential of the function, which is 2x plus 1. So here I can say that my second derivative shall be a positive 4 and 2x plus 1 to the power negative cube, and the differential of 2x plus 1 is just a 2, and I can say that the second derivative here, d2y by dx square, shall be equal to 8 divided by 2x plus 1 the whole to the power cube here. So this shall then be the answer for the second derivative of the y equation in terms of x. Second part of the question says, find the coordinates of the stationary point. Let's underline the stationary point and determine the nature of the stationary point. So stationary point, to get the stationary point, what we know is that the first derivative, this is the understanding that we have, for the first derivative, for the stationary point, the first derivative shall be equal to a 0. And for the nature of the stationary point, I will be taking help of the second derivative, which we have already found in part A. So stationary point. So to get the stationary point, I have the first derivative from part A, which was 2 minus 2 over 2x plus 1 the whole square. So to get the stationary point, the first derivative needs to be a 0. So this then shall be equal to 2 minus 2 over 2x plus 1 the whole square. Or to solving it further, I can say it's 2 over 2x plus 1 the whole square, which then shall be equal to the 2. The 2 here gets simplified, and I can say it's 2x as a 1. Let's write it as a 1 here. And then I can say it's 2x plus 1 the whole square, which equals a 1. So to get the value of x, I shall be taking the square root of this positive 1 on the right side, so that this becomes 2x plus 1, which shall then be equal to a plus minus 1. So solving it further, I can say it's 2x, which is equals to 1 minus 1, and also I can say it's 2x, which is equals to a negative 1 and a negative 1. So from here our x becomes a 0, and 2x then becomes a negative 2, or x then shall be equal to a negative 1. So these are the two stationary points that I have for this question. But if we look at the question, it has already said that x needs to be greater than negative 1 by 2. So all the values which are less than negative 1 by 2, I should say that this value here is not possible, and the only x coordinate that I should be having not possible, I will write the condition because x needs to be greater than negative 1 by 2, as x needs to be greater than negative 1 by 2. So the x coordinate that I should be considering here is x is equals to 0. To get the y coordinate, I will be substituting x as a 0 in the equation, which was, so in y equals 2x plus 1 over 2x plus 1, if I substitute x as 0, I shall be getting a 0 plus 1 divided by 2 times 0 plus 1, or I can say that my y coordinate here is a 0 plus 1, a 1, and then 1 divided by 1, which is a 1, or I can say that the y coordinate needs to be a 2 here. Therefore, the stationary point here is when our x is a 0 and our y is a 2, meaning it's going to be the y-intercept here. So this is the stationary point. The second part of the question says find the nature of the stationary point. So for the nature of the stationary point, I will be taking help of the second derivative, which was second derivative equals 8 divided by 2x plus 1 to the power cube. So when x is a 0, I can see that my second derivative with x as 0 is coming out to be a positive, meaning it's greater than 0. I will show it here also. It's 8 divided by 0 plus 1 the whole cube, and this equals 8, which is greater than 0. So as soon as the second derivative comes out to be greater than 0, we know that it has to have a minimum nature. So this needs to be the nature of the point, minimum nature or minimum stationary point at 0 and 2. So I can say that it's a minimum stationary point at 0 comma 2 here. So this is how the first question for differentiation from the past papers can be solved, and we will be moving to the next question now. Second question that I have chosen is from summer 2020, and it's paper 1 variant 2, and it's question number 3. So the question says a weather balloon in the shape of a sphere, let's underline the keywords. It's the weather balloon, which is a sphere, is being inflated by the pump. The volume of the balloon is increasing at a constant rate of 600 centimeter cube per second. So the balloon was empty at the start of the pumping, meaning when time is 0, the volume was also 0. So find the radius of the balloon after 30 seconds. So here we have this sphere, we have this balloon in the shape of a sphere, and the volume of the balloon is increasing at the rate of, meaning here it's dv by dt, which is given to us, and this dv by dt is equal to a 600 centimeter cube per second. Balloon was empty, meaning the volume here was a 0, and this was when the time is also 0, because at the start of the pumping the volume was 0. So we need to find the radius of the balloon after 30 seconds. So to get the radius of the balloon after 30 seconds, what we know is that volume was 0 when time is 0. And they have given us dV by dt, meaning the rate of change of volume, which is equal to 600 centimeter cube per second. Meaning in 1 second, this balloon, this spherical balloon, has been inflated by 600 centimeter cube here. So if I just write it, I can say in 1 second, the balloon has been inflated to 600 centimeter cube. So that means in 30 seconds, the inflation of this balloon should be a 30 times a 600, which then shall be equal to an 18,000 centimeter cube. So therefore, in 30 seconds, the balloon's volume is 18,000 centimeter cube. So if they are saying find the radius of the balloon after 30 seconds, then we know if after 30 seconds the volume is 18,000, I will be substituting this in the volume equation for sphere. I can say that the volume here is 18,000, for which the formula says it's 4 by 3 pi r cube, and this is how I will be getting this radius now. So I can say that it's r cube, which then is equals to 3 times 18,000 divided by 4 pi, or taking cube root on both the sides, I can say that this is going to be a 54,000 divided by 4 pi, and this is whole to the power 1 by 3. So from here I can get the radius, and this radius comes out to be, so this radius comes out to be a 16.3 centimeters. Part B of the same question says find the rate of increase of the radius after 30 seconds. So this means here they are asking for the rate of increase of the radius. That means they are asking about dr by dt after 30 seconds, meaning when our time is 30 seconds. So we already know that when time was 30, the radius of this balloon from part 3 was 16.3 centimeters, and we also knew the volume, and this volume was 18,000 centimeter cube. This is the data that we have already calculated. So if they are asking for dr by dt, then we know that if this volume is a 4 by 3 pi r cube, then dv by dr, we are going to form the chain rule here. dv by dr, that then shall be equal to a 4 by 3 pi times 3 r square. The 3 gets cancelled, and here I will be left with dv by dr, which is equals to a 4 pi r squared. This actually is the surface area of this spherical balloon. So we have this surface area. We can get this surface area when our radius is a 16.3, and this then shall be equal to 4 pi times 16.3 the whole square. So 16.3 the whole square. So this dv by dr, it comes out to be a 338.7 76 centimeter square. So this this dv by dr value, it comes out to be a 338.76 centimeter square. dv by dt, if we make the chain rule, then we can say it's dv by dt, which was equal to dv by dr, and then this shall be equal to dr by dt. And here we are supposed to find this value, which is our dr by dt. So dv by dt, we already know that dv by dt is given in the question as a 600 centimeter cube per second, which then shall be equal to dv by dr, calculated as 4 pi 16.3 the whole square times dr by dt, and this is what we are supposed to find out. Therefore, dr by dt shall be equal to 600 divided by 4 pi 16.3 the whole square, and then dr by dt shall be equal to 0.181 centimeters per second. So this is how then this question needs to be solved. So question number 3 is chosen from February March year 2020, and it's question paper 1 variant 2, and it's question number 1 in the paper, and it says that the function f is defined by fx, which is equals to 1 over 3x plus 2 plus x squared for x to be less than negative 1. Determine whether f is an increasing function, decreasing function, or neither. So we know increasing function is when our gradient is greater than 0. Decreasing function is when it is less than 0, or neither, meaning it shall be equal to a 0. We will not be able to solve for dy by dx for any value of x. So let's see what happens if our f of x is given as I will again be taking the denominator to the numerator, so that it's 3x plus 2 to the power negative 1 plus x squared, and we already know the condition. It needs to be, x needs to be less than negative 1. So f prime x, so to get our f prime x, it should be negative 1 times 3x plus 2, negative 1 and a negative 1, and then I should be differentiating 3x plus 2, and then I should be having a 2x for the differential of x squared. So f prime x then shall be equal to a negative 1 divided by 3x plus 2 to the power of 2, and then the differential of 3x plus 2 will be equal to a 3, and then it's a plus 2x. So here I can very easily say that our f prime x shall be equal to a negative 3 divided by 3x plus 2 the whole square and a plus 2x. So this is the first differential of this question. So with this, f prime x has a negative 3 divided by 3x plus 2 the whole square plus 2x, and the given condition here which says that x needs to be less than negative 1, x needs to be less than negative 1. So that means all the x values here, they are going to be having negative values. So if they are having negative values, we know that the denominator with the negative value will always be a positive because of the square here. Negative positive will give us a negative term, and then x needs to be less than negative 1. So this term also will be a negative value. So negative and negative, they are going to give us a negative answer. So for x to be less than negative 1, I can see here that all the first differential values, they are negative, meaning they are less than 0. Therefore, the nature has to be a decreasing nature. If they are less than 0, then the nature has to be a decreasing nature. So, or a decreasing function that we shall be having over here. So this is how then this question needs to get solved. So the fourth question is chosen from Winter 21, and it's paper 1 variant 2, and it's question number 11. And the question says, the diagram shows the line x equals 5 by 2. This is the line x equals 5 by 2. Part of the curve y equals 1 by 2x plus 7 by 10 minus 1 over x minus 2 to the power 1 by 3, part of this curve. And the normal to the curve at the point A with coordinates 3 and 6 by 5. There is this normal to the curve at A with coordinates 3 and 6 by 5. Find the x-coordinate of the point where the normal to the curve meets the x-axis. So I need to have the x-coordinate of the point where the normal to the curve meets the x-axis. So when it meets the x-axis, one thing is very much clear, that this point shall be having the x-coordinate and the y-coordinate needs to be a 0. So this means that we are supposed to find this coordinate here, let's call it point B, where it has the x-coordinate and the y-coordinate is a 0. For that, to do some mind mapping, we should know that to get the point B, first thing is to have the equation of the normal. So to get the equation of the normal, we know that the normal is at the point A with coordinates 3 and a 6 by 5. So the other thing that I know is the gradient of the normal. So the normal is present on the curve with the equation, which is y equals 1 by 2x plus 7 by 10 minus 1 over x minus 2 to the power 1 by 3. So that means to get this normal, to get this gradient, I shall be differentiating the equation. So to differentiate the equation, I can say it's a y which is equals to 1 by 2x plus 7 by 10, and here again I'm taking the denominator to the numerator with negative 1 by, with the power as negative 1 by 3. So if I get the gradient here, it's dy by dx, then dy by dx shall be equal to 1 by 2x, the differential is a 1 by 2, plus 7 by 10, the constant gets eliminated, and then minus x minus 2 to the power negative 1 by 3. So I will say it's a negative times negative 1 by 3, and x minus 2 to the power negative 1 by 3 and a negative 1, and then I should be differentiating x minus 2 here. It's the chain rule that I'm following to get my differential. So my dy by dx value here becomes a 1 by 2 plus 1 by 3 and x minus 2 to the power. Now minus 1 by 3 and a minus 1 is a negative 4 by 3, and if taken to the denominator, I should say it's a positive 4 by 3 here. And then the differential of x minus 2, that's just going to be a 1. The differential of x here is a 1. The differential of x is a 1, and negative 2 gets eliminated. So I have this gradient, which is the gradient of the tangent, and this gradient shall be 1 by 2 plus 1 by 3 times x minus 2 to the power 4 by 3. Now to get this gradient value at the point A with our x coordinate as 3, I can just substitute x as a 3 here to get the gradient of the tangent. So gradient of the tangent then becomes 1 by 2 plus 1 by 3 and 3 minus 2 to the power 4 by 3, which is 1 to the power 4 by 3. That will give me a 1. Here I should be having a 1 by 2 plus 1 by 3, or further I can say that the tangent gradient shall be equal to a 5 by 6 here. So if this tangent has the gradient which is a 5 by 6, then I can say that the gradient shall be having the normal shall be having the gradient which should be a negative 6 by 5. And this is when our A has coordinates 3 and a 6 by 5. So equation of normal then shall be obtained with the equation y minus y1 equals the gradient of the normal times x minus x1. So I have x1, y1, the A coordinates 3 and 6 by 5. I have the gradient of the normal. I can simply substitute all these values and I can say it's a y minus 6 by 5, which then shall be equal to a negative 6 by 5 and x minus 3 here. So this is the equation of the normal that we have, and in this equation the question has said that the normal is intersecting the x-axis, and we have to get the x coordinate of the point where the normal to the curve meets the x-axis. So we have already decided here that our y coordinate needs to be a 0. So just to get the x coordinate here, I already know that my y should be a 0, and if I substitute this y as a 0 here, I will be left with a negative 6 by 5, which is equals to negative 6 by 5, and then this becomes x minus 3. Negative 6 by 5 gets cancelled. I will be left with a 1, which is equals to x minus 3, and I can say that the x coordinate here becomes a 4. So this is how this equation can be solved and I can say that where it intersects the x-axis, the coordinates are, the x coordinate here is a 4, and the b shall be having the coordinate as 4 comma 0. So the next question is taken from Winter 21, and it's paper 1 variant 3, and it's question number 10 in the paper. And the question says that the curve has equation y equals fx, and it is given that f prime x is equals to 1 by 2x plus k to the power negative 1 by 2 minus 1 plus k to the power negative 2. K is a constant and the curve has a minimum point. Now this is the key word that we should be underlining. It has the minimum point at x is equal to 2. So whenever we have the minimum point, we should know that at this point our gradient then shall be equal to 0. So this is the information that we have from this statement. They are saying find f double prime x, meaning the second derivative, in terms of k and x, and hence find the set of possible values of k. Set of possible values of k here. So let's start working on this question. So with respect to the minimum point condition, we know here that our f double prime x, it should be greater than 0. So that is why they are asking for the set of possible values of k. So let's start working on it. The first derivative is given as a 1 by 2x plus k to the power negative 2 negative 1 plus k to the power negative 2 here. To find the second derivative, f double prime x, it should be a negative 2 times 1 by 2x plus k to the power negative 2 negative 1, and then the differential of 1 by 2x plus k. And then in the second part we have this constant, and then over here we have this constant which is 1 plus k to the power negative 2. I can see that there is no x here, it has to be a constant value. So when I take the second derivative, this function here, this needs to get eliminated. So this gets eliminated here. So f double prime x now is going to be the second derivative, f double prime x, this should be a negative 2 and 1 by 2x plus k to the power negative 3 times a 1 by 2. The derivative of 1 by 2x is a 1 by 2 and k gets eliminated. So here the 2 gets solved and I will be left here with a negative 1 by 2 x plus k to the power negative 3, and this needs to be greater than 0 because it has to be a minimum point. The curve should be having a minimum point over here. So solving for the negative sign, we know that the sign of the inequality should get changed so that this is 1 by 2x plus k to the power negative 1 by 3, which should now be less than 0 here. We know from the question that this condition appears for the minimum point when x is equals to 2. So if our x equals 2, I can simply substitute this x as a 2 here, and substituting that, it's plus k, which should be less than 0. The negative 3, the power negative 3, obviously it gets simplified by just if I just equate it to 0 to the power 1 by 3 or a negative 1 by 3, obviously that means nothing and the power gets solved here. This power, it gets solved here by just simplifying. Even if I simplify this for 1 by 3 or a negative 1. So obviously 0 to power negative 3, that does not mean anything. So this means we can simply ignore the power here. We can simply ignore the power here and we can simply say that this is 1 by 2 into 2 plus k, which should be less than 0. So the 2 here again gets simplified. I'm left with 1 plus k to be less than 0, or I can say that the set of possible values of k should be k to be less than a negative 1. So this is how we shall be getting the set of values of k for this question. So this is all for this video, where we have done 5 questions from past papers regarding differentiation, and this is part 1 of this topic, past paper questions. So I'll meet you in the next video, part 2 for differentiation past papers questions. Till then, take care and Allah Hafiz.